Two blocks as shown in figure P10.71 are connected by a string of negligible mass passing over a pulley of radius 0.25 meters and a moment of inertia I. The block on the frictionless incline is moving up with a constant acceleration of 2 meters per second squared. A, determine T1 and T2, the tensions in the two parts of the string. And B, find the moment of inertia of the pulley, and they give you a diagram here. So the first thing that I did was I just redrew this diagram. We have mass 1, mass 2 connected by a pulley. We know that this is a frictionless incline, so there's no force of friction opposing the constant acceleration of 2 meters per second squared. We also know that if it is connected by a pulley, the fact that this M1 is accelerating at 2 meters per second squared also means that this M2 is accelerating at 2 meters per squared down. Next, I just did the component forces for everything. So we know that there is the normal force that is directly perpendicular to the incline. We know that there is a weight that is directly down. And so because we know that this is 37 degrees, I just compounded it out. So this is cosine 37 mg, which is negative if we have this and this as our positive x and y axis. And then we have negative sine 37 mg, which is opposing the tension. And then here for mass 2, we just have tension 2, which is going up, and we have m2g, which is going down. So the first thing they want you to ask is just simply, we're doing sum of forces equals mass times acceleration, net force equals mass times acceleration, in order to find tension 1 and tension 2. So first, I'm finding tension 1. The sum of the forces in specifically this x direction equals tension 1 positive, because it is pulling in the direction of motion, minus sine 37 or sine theta mg equals mass times acceleration. So that means tension 1 minus sine 37 mg, which is also 15 kilograms times 9.8 meters per second squared, equals 15 kilograms, that's the mass of this object, times the acceleration, which is given as 2 meters per second squared. So once you separate this out and you isolate the T1, we find that the tension of the first string here is 118.47 newtons. Next, we're going to do the exact same thing for the mass 2, except now we're going in the y direction. So because there's no x direction, we don't have to worry about that. m2g, which is in the direction of motion, so positive, minus t2, which is opposing motion, equals mass times acceleration. They give us our mass is 20 kilograms, and the acceleration of gravity is always 9.8 meters per second squared, minus T2 equals the mass of the second object, which is 20 kilograms, times the acceleration of the entire system, which was already given at 2 meters per second squared. So I think the trickiest part about this one is just figuring out that the acceleration is 2 meters per second squared, because the acceleration of one block in the system is the acceleration of the whole system. And so that means that the second tension is 156 newtons. So now they're asking us specifically for the moment of inertia of the pulley. And so I redrew the diagram for the pulley. Here, tension 1 is pulling this way, and tension 2 is pulling this way, which is the opposite of what it was pulling on the block. And we know that the radius is 0.25 meters. And so now it's the sum of torques equals moment of inertia. So the net force of torques is negative T1, because that is our force, times the radius of the pulley, because that's where it is being applied, plus T2 radius equals moment of inertia times angular acceleration. For angular acceleration, they already give us regular acceleration, which is 2 meters per second squared. So using this formula, we can isolate and solve for angular acceleration, which is just regular acceleration, which we already know is 2 meters per second squared, over r. So now we're just plugging in the values that we found here and here for tension 1 and tension 2. And what you get is negative 118.47 newtons plus 156 newtons times the r's, and also times the r here, which is r squared over 2 equals I. And then r is 0.25 meters, so if you just square that, you have the sum of this over 2, you get the moment of inertia of the pulley is 1.1728 kilograms meters squared.